The most rational way to determine the number of Kanban cards to release into a loop that you are setting up is arguably the Kanban card formula. That is actually the formula that this question right here is hinting at. The average usage rate, D, of some component is 200 an hour. The lead time, capital L, on a container for that component is 1 hour. The container contains 110 parts, and assuming a policy variable of x equals 0.1, how many Kanban cards, right, there's a formula, should be used to control production? What were these parameters right here for? The Kanban card formula is D times L times 1 plus X divided by C. And as you can see, a lot of what we need for this formula was actually mentioned by name. D is the usage rate of the item that's being controlled. It said D of the component is 200 an hour. L is the lead time on a container. It said 1 hour. I'm just listing this information separately. Each container holds 110 components. Now, it didn't specify this exactly, but it did give us C. C is the size of the container. That's what the C is meant to invoke. Oh, okay, so even though it didn't call it by name in terms of the formula, C equals 110, but then it did mention that this X, the policy variable, is 0.1. Okay, now what? Just fill out the formula. Just fill out the formula. So in our case, it's 200 times 1 times 1 plus 0.1, right, that right there, divided by the 110 goes in the denominator. Well, I did that and I got 220 divided by 110, or 2. Perfect. There's the answer to the question. You should have 2 Kanbans in that loop, 2 cards. Now, little footnote. Just so happens with this particular problem that when we did this arithmetic in here, it came out to an even number. All right, suppose that it hadn't, like it had come out to 2.21754. Well, there's no such thing as 2.1754 cards. You're going to recommend either 2 or 3 cards. With this Kanban card formula, there's no strict rule whether you should always round up or round down. Basically, your recommendation at that point, if we'd gotten a decimal place, would have been 2 or 3. If you round up, you are theoretically adding a little bit of inventory to the system, more so than what was specified. If you round down, you are theoretically trimming the system a little leaner than what was specified. But obviously, you're going to have to use a round number. All right, now, the next question looks really similar. The usage rate of a component is 200 an hour. The lead time is 1 hour. Déjà vu. We were just working with those numbers. Each container holds 22 components. With this next question, we have a smaller container. Now wait, I'm assuming a policy variable of x equals 0.1. We have the same situation as previously, except we have a smaller container. We have the same question being asked. How many Kanban cards, which indicates we should use the same formula. So I'll just fill out the formula again. All right, so that's 200 times 1 times 1 plus 0.1, or 1.1, divided by, only the denominator changed from when I did this last time, divided by 22. I get, that comes out to 10 even. Oh, the answer is 10 cards, 10 Kanbans. Interesting. Notice that if you'd worked the problem before, you got an answer of 2. You work this particular problem, you get an answer of 10. The only difference between the two situations is the actual container that's being tagged with cards is a lot smaller. right? The smaller the container, the more cards you're going to need in order to build up the system inventory to a certain level. The larger your containers are, and generally speaking, everything else being the same, the smaller the number of cards you're going to need, because you just don't need that many containers laying around. They're pretty big. They have a lot of stuff. Oh, now the next question should likewise seem very familiar, because it also opens with the usage rate of a component is 200 an hour. Got it. And the lead time on a container is 1 hour. Got it. Oh, and a container holds 22 components, so we're keeping with that really small container size. The only difference here is it says assuming a policy variable of, x is larger in this case, 0.21, how many Kanban cards should there be? That means, yep, same formula, n equals d times L times 1 plus x divided by c. Just fill out the formula. Okay, now in this particular case, it's 200 again times 1 times 1 plus 0.21 or 1.21 in the numerator, divided by the little container size 22 in the denominator. I get that that comes out to be 11 even. So the answer then to this question is you should use 11 Kanbans, 11 cards. You should release 11 cards into the loop. All right, now previously, the question before, everything was the same except that x policy variable, and the answer was 10. You should release 10 cards into the loop. This one, the only thing is that we bumped up that policy variable just a little bit, and all of a sudden we've added another card to the loop. Yes, that's what that parameter x does. It's in a certain sense a safety factor. If you dial it up as management, you are adding cards into the loop, which means you're allowing more containers to be full, which means you're keeping a little bit more stuff around. If you decide it should be a really, really small number, you dial it down. Right, you're taking cards out of the loop, you're drawing down the number of full containers, and you are forcing the system to run leaner.